Hey there, so we're going to continue studying a review of functions, and in this video we're going to talk about piecewise functions. So what is a piecewise function? I have a little graph here to show you. So this is an example of a piecewise function. So essentially it's a function that, as its name says, is graphed in pieces, and thus it is defined in pieces as well. So this has to be a function, so I'm going to kind of draw some complete the graph here. You don't have to have the arrows. This just indicates that it goes on to infinity. If you don't have them, that just means the domain will end right there. But if you see the arrows, that means it goes on to infinity or negative infinity. If it's a dot there, that means that's where the function ends. But here at 0, I want to make sure that I still have a function. So one of those needs to be open and the other one closed, because otherwise we are not going to pass the vertical line test. So I'm going to put an open circle here on 0 and say that's not open, and I'm going to close it over here at, what number is that? -3. So that now is a function. If both are solid, right, notice that then they won't pass the vertical line test. A piecewise function is still a function, so we should be able to pass the vertical line test. So if you draw a line anywhere, you should pass the vertical line test. That's a good test for when you're graphing them on your own. You want to make sure that your final product of what you think is the graph of your piecewise function is a function. So draw a vertical line test, imaginary vertical line test, right? Imagine a vertical line, sorry. And does it touch only once? So here I have the issue that it may not, right? If both of those are solid, then it's not a function. So I have to open one up and leave the other one solid. And so now I could define this function, right? So if this is the function f, what might be a rule for f? And just looking at the graph, I can find values of it. So for example, what is f of 2? What is that equal to? Well, I'm going to go to 2. Here's 2, and I'm going to follow that and see where that lands. And so based on my scale here, that appears to be -1. So I can say f of 2 is equal to -1. What about f of -1? What is that equal to? I'm trying to find things that are in the frame. So here is x is -1. So this is the function value, which appears to be 1. So f of -1 is equal to 1. What about f of 0? What is f of 0 equal to? And so here we can see, well, 0 is here, and it does not have two values, right? That one is open, so that means that f of 0 is not equal to 0. This one is the one that's solid, so f of 0 is equal to -3. This is -3 over here, which is the value of when x is 0. All right, so that's how we find values given the graph of a piecewise function. Can we find the rule? Yeah, so this is -1 goes to 1, -2 appears to go to 4. So this is looking like the parabola y equals x squared. And what about this one? Well, I see the y-intercept is -3. And what is the slope? The slope appears to be 1, right? Notice that you go up 1 and over 1, up 1 over 1, up 1 over 1. So this is a line. M equals 1, and looks like the y-intercept is -3. So putting that together, I get y equals x minus 3. So we can then find a rule for f of x will be that is the parabola y equals x squared for the values less than 0. So for x less than 0, not including 0 because that is open. And we look like the line x minus 3 when x is greater than or equal to 0. Notice that for all the positive values of x, we're looking like this line, which is the line of slope 1 with y-intercept -3. And so this will be the rule for the function. And when you graph it, it has to pass the vertical line test. So now what if we have a function that we need to graph? So graph the piecewise function. So now the rule is given, and we need to come up with the graph. All right, so when graphing piecewise functions, I look at how many pieces are there and how is the domain split up. So I have two pieces. So I have the piece where y equals x squared minus 2x plus 1 for x less than 2. So I'm going to work on that piece, and then we're going to explore the other one. So this domain, because I only have two pieces, that means the domain, meaning the minus infinity to infinity, this is the domain, has been split into two pieces. The values for when x is less than 2 and the values when x is greater than or equal to 2. So essentially, my piecewise function is splitting the domain into minus infinity to 2 and then 2 to infinity. And so 2 is what I call the split point. So I'm going to go, let's see, 1, 2, 3, 4, 5. So 2 over here is my split. So that's what I call the split point. So that's where things kind of happen. So on one side of 2, on the left side of 2, we look like one thing, and on the right side of 2, we look like something else. When it's split into 3 pieces, I still like to do the interval notation of what my domain looks like, so that then I can see for each piece of the domain, what do I look like? So when x is less than 2, that means minus infinity to 2. In this piece, we look like the parabola. Hopefully you recognize that this is a parabola. And for the other piece, we look like the absolute value function. So then I know, okay, so my split point is here too. So I'm gonna just draw this line as a just reference. This is not gonna be part of my final graph. But so to the left of 2, I'm gonna look like the parabola on this side. And on the right of 2, we're gonna look like the absolute value. Will I still pass the vertical line test? Will this still be a function? Yes, right? A parabola is a function. So when I graph my parabola, part of the parabola that falls here, it should pass the vertical line test. When I graph the absolute value, the part that falls on the right of 2, it should pass the vertical line test. If you graph a piecewise function that doesn't pass the vertical line test, you know you've done something wrong. Maybe you've graphed the 2 pieces together, or you've graphed the entire functions on minus infinity to infinity without splitting up the domain. So now let's graph it. How do I graph the parabola? Well, we have to remember all the things about graphing a parabola. So I know, what do I know about a parabola? Well, the y-intercept is when x is 0, so y is going to be 1, right? 0, 0, and then you have 1. I need to find the vertex. The x-coordinate of the vertex is given by minus b over 2a. So in this case, what's b? So you have a is 1, b is minus 2, c is 1. So this is going to be minus 2 by negative b over 2a, 2 times 1. So I get positive 2 divided by 2, that's 1. So the vertex of my parabola, the x value is at 1. What is the y value? It's going to be your f of x, in this case f of 1 for the vertex. So plug in 1 in here, so what are we going to get? When you plug in 1 into your function, f of 1 will be 1 minus 2 times 1 plus 1, so essentially 2 minus 2, which is 0. So then I know that the vertex of this parabola is going to be at, the x value is 1, and the y value is 0. So I know I'm going to be over here, so that's going to be the vertex at 1, 0. And I want to know what is the value at 2, my split point. So our split point is x equals 2, so I need to find f of 2. So when x is 2, then y in y equals x squared minus 2x plus 1 is equal to, what's that? 2 squared minus 2 times 2 plus 1. So 1. So that will be how high my parabola goes. So it's going to go to there, and looking at the rule is not going to be included. So I'm going to have a hole here. So let me start another grid so that it's cleaner. All right, so here I have my other grid. So now I know, what do I know about this, the left side? I know that we have the vertex of the parabola is at 1, 0. So let's plug that in here. So it's at 1, 0, and we know that at our split point, so when x is 2, the y value is 1. So at 2, we're going to have 1, and it's not included. And the nice thing about a parabola is that it's nice and symmetric. So since my vertex is here, that means that I have to have a mirror image point, but we already knew the y-intercept anyway was 1. So then I can complete my parabola, and since the domain goes to infinity, then we continue it and put an arrow there to indicate that it keeps going. So this is the part of the parabola that is the part of the function that is to the left of 2. So that's what we had said was the parabola. Now what about the absolute value? To the right of 2. So now let's look at the other side. So when y equals the absolute value of x minus 1 for x greater than or equal to 2. So what does the absolute value of x minus 1 look like? Well, this is a V-shaped graph. I'm not sure how long has been since you took your pre-calculus or algebra class, and but absolute values look like a V. So is the V-shaped graph, where is the vertex, and what is our split point? So this, right, the absolute value of x usually is like our standard V. So what does y equals x minus 1 look like? So this has undergone a transformation. So the vertex has moved to 1. So you still have your V, but now it looks like that. So it's going to start here at 1, but that's part of this is to the left of 2, so we don't need that. So we're going to go to find our split point, right, with when x equals 2. So when x is 2, y, what is y equal to? For y equals the absolute value of x minus 1, y equals the absolute value of 2 minus 1, which will be just the absolute value 1, which is 1. And so at our split point for this graph, right, is going to be here 2. So you'll go to 2, 1, and that will be included. So we essentially want this part to be graphed up there. And so we're going to have our absolute value. So imagine if you were drawing V, it would be a very straight line, not curved like this parabola, and then it will continue here. Now, here, right, our parabola is going to, at 2, we just noticed that then is equal to 1. So it fills in that point, and then it continues like a line, right? So that means that at 3 is going to be a 4, and so on. So you're going to graph your, or at 3 is going to be 2, sorry. And so you're going to graph your line. So it looks a little more straight. So this should be a little more curved, and then you have your absolute value. So this is y equals absolute value of x minus 1, while this side is equal to y equals x squared minus 2x plus 1. All right, and that's how you graph a piecewise function. You may have a rule like we did in the other function where there's a split, and that's okay. And if I could move this so that it was just y equals x instead of y equals x minus 3, then this line will move up here and fill in that gap and then continue as a line. So that's what's happening here. All right, so email me if you have any questions regarding piecewise functions or if you would like to see more examples.